lines in three-dimensional space R3. So here we will give certain equations of lines. So first one is this: an equation of the line passing from the point let's say P sub 0, X sub 0, Y sub 0, Z sub 0, and parallel to the given vector, let's say D, P, Q, and R. So what is the equation of this line? The line is passing from a point and parallel to the one vector. Okay, let's say our line is this. This is our line. So here we have a point, let's say here, or let me choose here, P sub 0. And we also have a vector here, let's say this vector. So this vector is parallel to our line. So these are the vectors. So this one is D. So P, Q, R. So to find the equation of this line, we need to find the arbitrary point. So let's say this is the arbitrary point. This one. Let's say this one is X. So the component is X, Y, Z. So if I find this X, because the line based on these points, so if I find these points X, Y, Z, then I will find the equation of the line. So because we are in three-dimensional space, we have an origin here. Let's say this is our origin. So I am trying to find this one, this position vector. Okay, this position vector. So to find this one is O. So I find this one. First, I come to this one, and then I go this side. So my point is this, and then goes this way. So if I write this equation, these vectors, then I obtain this one. OX is OP sub 0 plus P sub 0 X. Now P sub 0 X is parallel to the D. This D is a vector. So it means P sub 0 X and D are in the same direction. So the orientation is not, may not be, and the magnitude, the length, may not be same, but the direction is same. So I can write this one for, let's say, T belongs to R. So P sub 0 X will be T times T. So I can write this one. OX is OP sub 0 plus T times T. Now let me put the components. OX is X, Y, Z. OP sub 0 is X sub 0, Y sub 0, Z sub 0. And T is P, Q, and R. Now from here we have X sub 0 plus X sub 0 plus T times P, Y sub 0 plus T times Q, and Z sub 0 plus T times R. So this one is X, Y, and Z. So this is the equation of this line. This one we call vectorial equation of the line. Let's say L. Because we are in three-dimensional space, so we can write in this form. X equals X sub 0 plus T times P. Y equals Y sub 0 plus T times Q. And Z equals Z sub 0 plus T times R. So this one is called parametric equation. Line L. So now if we write these all equations in terms of t, so if we take out these t, so then we obtain this one, x minus x sub 0 over p, y minus y sub 0 over q, and z minus z sub 0 over r. This one is called the Cartesian equation, or sometimes they call the symmetric. Symmetric. Symmetric equation of the line. So here, all these equations, P, so this one is D, P, Q, R is called the direction of the line PQR. X sub 0, y sub 0, z sub 0, this is P sub 0, is the point where the line passes. So we have three types of equation, the vectorial equation and the parametric equation, and the last one is Cartesian equation. So this T is the parameter. Actually, this T determines the line, because every time T takes some values and our line consists. In the practical part, we first construct the Cartesian equation and then we find the other equations, because it will be easy to first find the Cartesian equation, because you know where this line passes and what is the direction of this line. So P sub 0 and D is given, then you can find this line. Okay, now let me give one example. Find the Cartesian parametric and vectorial equations of the line passing through the point 1, -2, 4, and having Okay, now we have P sub 0 as 1, negative 2, 4, and D direction vector 2, 3, 5. So if I use the above equations, this one, so then I can write this one. X minus 1 over 2, y plus 2 over 3, and z minus 4 over 5 equals t. So this is the Cartesian equation. From this we have x equals 2 times t plus 1, y equals 3 times t minus 2, and z equals 5 times t plus 4. So this is the parametric equation. So this one is Cartesian equation. So if you write this one, x, y, z, as 2 times t plus 1, 3 times t minus 2, 5 times t plus 4. This is the vectorial equation. So our point is 1, 4, 2, 4. Yeah, negative. Is a point on the line. Our direction vector is 2, 3, and 5. You see, this is our line, this colorful one, and this is our direction vector. Direction vector is parallel to the line, and the point, this point is the point on the line. So this is the line passing from 1, negative 2, 4, and having direction this vector. This vector is 2, 3, 5. You see this vector, this line does not is not passing from the x-axis or y-axis, okay? Okay. Now another equation, let's say 2, an equation of the line passing through the points let's say A, P1, P2, P1, maybe I should write X sub 1, Y sub 1, Z sub 1, and B, X sub 2, Y sub 2, Z sub 2. The idea is same. Again, we have a point line here, let's say. So you have 2 points. This is A, this is B. So then our, let's say, origin again is here. So then we put the arbitrary point here. Let's say this X. X is again X, Y, Z. So we are trying to find the, let's say this O. So what is OX? We are trying to find this one. Because if I find this one, it means you find the arbitrary point on the line. So in this way you can find the line itself. First, so I am trying to find this one. Okay, this vector. To find this one, first I can, okay, to find this one, first I came to this point, then I go this way. Okay, so here and here. So to write the OX, I have this one. OX is OA plus AX. But again, AX is parallel to the AB, this line segment. So it means you can write AX as T times AB. So now put this information here. OX is OA plus T times AB. So this one is X1, Y1, Z1 plus T times, this one is X2 minus X1, Y2 minus Y1, and Z2 minus Z1. So from here, OX becomes X1 plus T times X2 minus X1. Y1 plus Y2 minus Y1. And Z1 plus T times Z2 minus Z1. Here we have T. Okay, so OX is this. This is again vectorial equation. So this is a vectorial equation of the line passing from the points A and B. Okay, now by using this one, so we have this one, right? Let me write again this equation. So actually we have this one. So this OX is this one. X, Y, Z. Okay. So from here, first we have this one. X equals x1 plus t x2 minus x1. Y equals y1 plus t times y2 minus y1, and z equals z1 plus z2 minus z1. So this is the parametric equation of the line passing through the points A and B so this is the parametric equation. I forget to put T here. There is a T. So this one should be familiar with you. If you take out this T, x minus x1 over x2 minus x1, y minus y1 over y2 minus y1, and z minus z1 over z2 minus z1 equals t. So this one, the Cartesian equation of the line passing through from the points A and B. Okay, let me give one example for this one. Find the equation of the line passing from the points 2, 1, 3 and 4, 0, 5. So we will use this equation. So you can write here x minus 2 over 4 minus 2, y minus 1 over 0 minus 1, and z minus 3 over 5 minus 3. So if you arrange this one, this is equal to t. So we have this one, x minus 2 over 2, y minus 1 over 1, and z minus 3 over 2 equals t. So this is the Cartesian equation. If you write in this form, x equals 2 times t plus 2, y equals t plus 1, and z equals 2 times t plus 3. So this is the parametric equation. If you write in this term, in this form, 2 times t plus 2, t plus 1, and 2 times t plus 3. So this the last one is vectorial equation of this line. Okay, this is the how we find the line, the equation of the line passing from the 2 points. Orthogonality, and parallelity. Okay, let's say we have two lines, x minus x1 or P1, y minus y1 or Q1, and z minus z1 or R1. This is one. The other line, L2, x minus x2 or P2, y minus y2 or Q2, and z minus z2 or R2. Okay, these two lines. Now from our previous lectures, we know two vectors are orthogonal to each other if their inner product is 0, right? So then we can write L1 and L2 are orthogonal if and only if, or let me write this way, these P1, Q1, R1 and P2, Q2, R2 is 0. Because the vectors, the direction vectors is this one, P1, Q1, R1, P2, Q2, R2. So it means these direction vectors should be perpendicular to each other. So it means their inner product will be 0. So how about the parallel? In this case, we know the cross product implies this parallelity. So L1 and L2 are parallel if and only if their cross product P1, Q1, R1, P2, P2, Q2, R2 will be 0. So consider this example. Check the parallelity and orthogonality of the blue lines. So let me write the lines. Let's say this is L1, x minus 2 or 3, y minus 3 or negative 2, z plus 5 or 1. This is L1, L2, x plus 7 over 2, y plus 5 over 3, and z equals 4. So L3 x over 4, x over 6, y plus 3 over negative 4, and z plus 10 over 2. So let me bring the other one here. So now let me write the points and the direction vector. The point here is negative 7, negative 5, and 4. And direction is, let's say D2, this is dP2. Direction vector is 2, 3, and 0. Because there is no z minus 4 over 0, so I write as a 0. And the other one, P3, this is the point, 6, no, 0, 0, negative 3, negative 10, and D3 is 6, negative 4, 2. So P1 is 2, 3, negative 5, and D1 is 3, negative 2, 1. So let me check. Let's look at the D2 inner product D3. You see they 12 minus 12, which is 0. So it means L2 and L3 are orthogonal. So how about D2? If you look at this D2 and D1, so let me check D2, D1. In this case you have 6 minus 6, so 0. It means L2 and L1 are orthogonal. Now L2 is orthogonal to the L3, L2 is orthogonal to the L1. So it means L2, so L3 and L1 are parallel. Actually you can see this one, because if you compare the D3, 6, 2, and D1 is 2, 3, 0. So you see D3 is equals 3 times D1. So it means D3 parallel to D1. Oh no, this is not correct, right? Oh, I thought this one is okay. This one should be, D1 is here, right? 3, negative 2, 1. 3, 3, negative 2, 1. So now it's correct. D3 is 2 times D1. So this implies D3 cross product D1 is 0. Okay, now let me give one more example. Find the equation of the line passing from -1, -1, 4 and perpendicular to both the vector 2, 3, 5 and the line x over 1, y plus 2 minus 2 and z minus 5 over 3. So if I write this, so we are looking for the line x minus x sub 0 over, so let me write this x sub 0 which is given 1 over, let's say, p y plus 1 over q and z minus 2 over r. Okay, so our d, the direction vector, is p, q and r. So if you look at the problem, it says this line, which is d, because d is the direction vector, d is perpendicular, the orthogonal to the both vector 2, 3, 5 and the line. So it means we have this one, d 2, 3, 5 will be 0 and d 1, negative 2, 3 will be 0. So this means that d will be cross product is 1, 2, 3, 5, 1, negative 2, 3. So if then I can find this one, this will be 9 plus 10, 19. So then 6 minus 5 will be negative 1 and negative 4, negative 3, negative 7. Okay, now we find the line. So our line is this, x minus 1 over 19, y plus 1 over negative 1, and z minus 2 over negative 7. So this is the line we are looking for.